All right, here is the problem 3 for Math 65. This one was a little bit tricky. I was trying to get kind of creative with it. Maybe I did, maybe I didn't. Let's see, so what we're given is we're saying this polynomial here times this polynomial here equals this big mess. So we got ax plus b times x squared plus 2x plus 3. And we know that that is equal to 5x cubed plus cx squared plus dx minus 12. Okay, so we want to first figure out what a and b is. We want to figure out what goes here and what goes here. The easiest way to figure out what a is to think about when you multiply this all through, which of these boxes is going to contain a term that has x cubed in it. And I claim that it's only this first box right here. This is the only one that will have an x cubed in it. Right? These will be x squared, these will be x squareds, x's, x's, and a constant term. So this right here is the only one that will have an x cubed in it, and we know that that has to be 5x cubed. Right? That's coming from this. So what that tells us is x squared times ax equals 5x cubed. So this a right here must be a 5. How do I do this? Maybe I'll draw a line out here and say so a equals 5. So a little bit tricky, not really a problem we did in class, but a bit of an extension from one. That same logic can help us figure out what b is equal to. And the way we'll figure out what b is equal to is by looking at this negative 12 right here. That's going to come from this box. It's the only box out of these 6 that will have a constant term in it, no x's at all. Right? These will have x cubed, these 2x squared, these 2x's, but this one won't have anything. So we got plus 3 times b has to equal negative 12. So from that, maybe I draw a line over here. Let's see, b would have to be negative 4, right? What do you multiply 3 by to get negative 12? You get b equals negative 4. And once we know that, we can figure out what c and d are by multiplying the two polynomials, right? We got, if a is 5, this is 5x, and b is 4, we got minus 4, and then x squared, 2x, and 3. And so if we multiply these polynomials and figure out what our answer is, we can just compare it to what we're given the answer is, and it'll tell us c and d. So let's see, 5x times x squared gives us 5x cubed. X squared times negative 4 gives you negative 4x squared. 5x times 2x gives you 10x squared. 2x times negative 4 is negative 8x. And 5x times 3 is 15x. And 3 times negative 4 is negative 12. So what I got is 5x minus 4 times x squared plus 2x plus 3 is equal to 5x cubed minus 4x squared plus 10x squared minus 8x plus 15x minus 12, which if I combine the like terms, only have one cubed term, but I have two squared ones, negative 4x squared and 10x squared. So that gives you 6x squared. Negative 8x and positive 15x. That nets out to being positive 7x, negative 12. So if you go back to the start, we had 5x cubed plus cx squared. So from here, we can tell that c has to be equal to 6. And then it was plus dx. So from this guy right here, we got that d is equal to 7. And I think that answers all the questions. So that is the end of the perfect problem, after I put these in boxes to be consistent. All right, that's the end.